Hello everyone, welcome to our video presentation. My name is Emiliano Padilla.
My name is Gonzaga García.
My name is Villegas, Emmanuel.
My name is Gaytan, Romero.
And today we want to show you how our project EcoGuardians work. EcoGuardians is an intelligent autonomous robot designed to find, recollect, storage and discharge plastic bottles in controlled urban areas.
To make this possible, we pre-featured a small camera system. We use a small built-in camera module that captures real-time images and process them to recognize the shape and presence of plastic bottles.
Once the robot detects the bottle, the mind electronic brain takes over the decision making. It sends commands to a second controller chip, which acts as the muscle of the robot, telling the power regulator to move the wheel motors.
Finally, when the robot reaches the bottle, a 3D printed wrapper mechanism, powered by high-strength motors, open to safely collect the bottle, storing it inside an internal compartment until it's ready to be emptied.
Speaking about the development process, our general experience was incredibly challenging, but rewarding. We had to combine knowledge from mechanic design, electric circuits, and programming into the single working machine.
I agree. It was fascinating to see how theoretical concepts we learned in class, like automatic control systems and how chips communicate with each other, actually came to life when the robot started moving on its own.
Working as a team was also a huge part of the experience. We had to sync our schedules, divide the tasks according to our strengths, and keep a detailed log of every single chance we made in the manuals.
Really opened our eyes to what real-world engineering looks like, saying the prototype successful. Grab it feasible after weeks of changing and improving the design gap use a great sense of accomplishment. Of course, it wasn't a smooth ride. One of the main issues we faced initially was that our original design was way too complex and expensive for our student budget.
To solve that, we simplified the robot's entire structure. We switched from expensive processing units to much more affordable and accessible chips, keeping the robot viable and easy to replicate.
Another major headache was energy consumption. When the camera, the wheel motors, and the gripper motors operated simultaneously, the battery would drain in less than 20 minutes.
We managed to tackle this by improving our programming. We set up the system to camera will go into an energy-saving mode. We don't need we schedule the motors and draw power only at the exact moments necessary, making the battery last much longer during the test.
In conclusion, EcoGuardian represents a huge step for us in terms of environmental awareness and technology integration.
It proved that low-cost technology system can offer real, scalable solution for urban recycling.
We want to thank our coordinator, Margarita Chavez, and our teacher for winning us.
Thank you all for watching, and this is how EcoGuardians works.
See you later.
Ciao.